Welcome to Learning with Philemon. In this video, we will be looking at the properties of ionic compounds. In the previous video, we saw how ionic bonding involves the transfer of an electron from a metal to a non-metal, forming a cation and an anion. Based on this dot and cross diagram of lithium fluoride, you may get the false impression that the compound consists of only two ions. This is not the case. Ionic compounds form an ionic lattice, which is a three-dimensional structure consisting of alternating anions and cations. The diagram on the left is showing one face of this cube. As can be seen, there are more than two ions present. Only a small section of the structure is shown, as the actual structure contains billions of ions. Note that the anions are bigger than the cations. For more information on ionic radii, check out the periodicity playlist. Remember that simple covalent compounds consist of only a few atoms per molecule. What holds the ionic lattice together is the strong electrostatic attraction between oppositely charged ions, the anions and the cations. Remember that opposites attract. The electrostatic attraction is represented by the two arrows in the 2D diagram. Due to this strong electrostatic attraction, it takes a lot of energy to separate the ions. As a result, ionic compounds have high melting and boiling points. For example, sodium chloride has a melting point of 801 degrees Celsius. Remember that simple covalent compounds have low melting and boiling points. Water has a melting point of 0 degrees Celsius. Sodium chloride is actually the salt we add to our food. Ionic compounds are brittle, which means that they are hard but break easily. In the ionic lattice, the layers are arranged so that anions are aligned with cations. There is an electrostatic attraction between the layers. However, if a pressure is applied, a layer can shift, as is seen here. Now the cation of this layer is aligned with the cation of the second layer. The anions are also aligned. Like charges repel, represented by the double-headed arrow, leading to this layer breaking off. Consider table salt, sodium chloride. It is a hard substance, but if you apply a bit of pressure, it breaks into smaller pieces, or even a powdered form. Ionic compounds are soluble in water. The oxygen in a water molecule, H2O, is slightly negatively charged. When an ionic compound is placed in water, the oxygen of a water molecule is attracted to a cation and breaks it off the ionic lattice. The hydrogens in a water molecule are slightly positively charged. The hydrogens of a water molecule are attracted to an anion and breaks it off the ionic lattice. This continues until all of the ions are broken off and there is no lattice left. A solution is created where the ions are moving freely amongst the water molecules. When you add salt to water, it seems like it has disappeared. However, what has happened is that it has dissolved. The ions leave the ionic lattice. Because all the ions are separate now, they cannot be seen with the naked eye. It seems like they have disappeared, but they are in the water. Ionic compounds conduct electricity when molten or dissolved in water. For an electrical current to flow, charged particles need to be able to move. In the solid state, the electrostatic attraction keeps the ions in place. Ionic compounds do not conduct when solid. However, when molten or dissolved in water, the ions are free to move. Salt water can conduct electricity. Remember that simple covalent compounds do not conduct electricity. Pure water, also called distilled or deionized water, does not conduct electricity. In conclusion, ions are arranged in a lattice in ionic compounds. Ionic compounds have a high melting and boiling point. They are brittle and soluble in water. They conduct electricity when molten or dissolved in water. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.